So we look at this quiz, and according to Gallup, about 33% of Americans polled said they frequently express stress in their daily lives. It's the fourth time for me to try to make this video, so I'm stressed. Hopefully no one will interrupt me now. Anyway, 33% is our P. That's the parameter because it's of all Americans polled. So that's our p-value. That's the parameter for our population. So it's 0.33. Q is 0.67. It says our sample size, a class of 45 students, and we're looking at no more than 12 students. So we have 12 stressed students as our X. And so from that, from our P and Q, our 45 and our 12, we then find P hat, which is 12 over 45. 12 divided by 45 is 0.26666. So we're just going to make that 0.27, which makes Q 0.73. These two added together should always equal 1. P plus Q is 1. P hat plus Q hat is 1. So we've got our P's, our Q's, our P hat, Q hat. So we find our standard deviation, which is the square root of PQ over N. That is according to our formula page. So that's 0.33 times 0.67 divided by 45 is 0.07. So then that gives us a z-score of p hat minus p over sigma. 0.27 minus 0.33 divided by 0.07 is is a negative 0.9. Now let's go back through and back here because it said to check all necessary conditions. So we're going to assume it's a random class of students. We know that 45 is less than 10% of all Americans. NP is 45 times 0.33. That's 15. So that's N times P. So that's greater than 10. 45 is times 0.67 is 30. That's greater than 10. So we're going to use a normal model. And in that normal model, we're going to construct this look. We know that on a normal model, 0 is our mean, 1, 2, and 3. When we find z-scores, 0 is our mean, 1, 2, and 3 standard deviations to the right, negative 1, negative 2, negative 3 to the left. And there's our negative 0.9, which is just a little bit greater than our negative 1. So we're finding the probability that x is less than or equal to 12, how often that occurs. So we do a normal CDF, which is taking the calculator, sorry I didn't have it handy, turning it on of course, and we're finding a normal CDF. And to find a normal CDF, we go second distribution, number 2. Okay, and so we're looking at that as a negative 100. We're looking at negative 0.9. Okay, that's my lower number and my upper number. Okay, because we're looking from here to the left or from way back over here all the way up to here, however you want to look at it. You could make that a negative infinity if it was already there. Our mean is 0 because we've got a normal model with our base of mean of 0 and our standard deviation is 1. So we then come here to paste. Okay, and I labeled this as lower, upper, my mean, and my standard deviation. So I find that percent, and it tells me it's 18.4% about. So the probability that x is less than or equal to 12 is about 0.184 or 18.4%. And that's what it asked us in the question. Find the probability that no more than 12 students. So we would assume that about 18.4% of the time, we would find 12 or fewer of the 45 students that were having daily stress. So it then asks, what if 20 students said that? So my new x is 20, which my n is still 45. Find a new p hat. 20 divided by 45 is 0.44. I then find a new z-score. 0.44 minus 0.33 divided by the same standard deviation that we found over here. This minus this is 0.11 divided by 0.07 is 1.57. That's my new z-score. So let's look at where that occurs. We can look at it here. 1.57, I threw up my walls at 2 and negative 2. Is this greater than 2 standard deviations? The question is, would we be surprised? And the answer to that should be no, because my z-score of 1.57 is not bigger than 2 standard deviations from the mean. There's 1.57 approximately. So that was no. Which leads us down to our next question. The average composite ACT score for Ohio students is 21.4, so I have a new model, 21.4. Standard deviation of 1.05. We're going to keep that for later. Random sample of 25 students. What is the probability, which is another CDF. Probability, the average composite score is 22 or more. So that's going to be from our starting at 22 greater. So we're going to identify the sampling distribution. So it's a normal distribution because it's an average set of kids, random sample, and it doesn't tell us any numbers, but it's a random sample. So we can use the normal model. Okay, and when in doubt, we make P 0.5, which makes Q 0.5. All right, but we don't need to use that. That could find NP and NQ. We don't know our number. Well, we have 25, so half and half makes 12 and a half, 12 and a half. So that's with our numbers. It was random, and 25 is less than all the students who took the exam to take the ACT. So we label our numbers. Now, notice I've got this here. We had to find a new standard deviation because we have to find the standard deviation for a sample of size 25. If this were a bigger number, this would shrink. Okay, excuse me. So we look at that. Our new standard deviation is 0.21. So I add 0.21, add 0.21, add 0.21, and I get right here. And so then we go back, wake up calculator, go back to our standard deviation, our normal CDF. Let me move that over here. So number 2. Now our minimum number is 22. They're wanting to know greater 22 or higher. So 22 or greater. So that's the reason why I'm shading here to the right. So this is 22. This, my upper number, well, what's the perfect score in the ACT? It's a 36. My mean is 21.4. Now this is just for the state of Ohio that we're talking about in 2003. So that's, so that's 21.4. My standard deviation is 0.21. Okay, and again, we're finding a normal CDF. 22 is my lower score, 36 is the max, my mean, my standard deviation, and the probability of the mean being greater than or equal to 22 is 0.002, so less than barely over 0.1%. Okay, so a couple of key things here again. One, if they don't give you a P and Q for success failures, we go half and half, which means out of 25 would be 12 and a half and 12 and a half. 25 is less than 10% of all the students who take the ACT in Ohio, and it said it was a random sample. So our conditions are met to use the normal model. Okay, I'm going to list those again. It said it was a random sample. $25 is less than 10% of all ACT takers. And 25 times 0.5 is 12.5, which is greater than or equal to 10. And that's on both successes and failures. Okay, so we use the normal model. So we can use the normal model. Okay, and it gives us this probability. Again, this is our final answer. So what is the probability? Is 0.002. Okay, enough said.